Okay, so this video is going to be about expanding laws. So we're going to look at a few, well actually not even a few, a couple of laws that have to do with exponents and how to make things simpler and how to expand out some stuff, so multiply some stuff together. So let's have a look at the first law. First law has to do with products. So when you have a product, in this case we have AB, so our product is A times B. When you have a product that is raised to a power, and here we've just put n can represent any number, you need to take that power, that exponent, and you need to apply it to each of the factors that make up that original product. So here you see that A is raised to the power of n, and B is also raised to the power of n. So each of the factors have to be raised to the same power. So written out for you, when you have an algebraic product raised to a power, that power needs to be applied to each factor of the product. Let's look at a couple of examples. So first example we have is we have AB, and that's raised to the power of 5. So that power of 5 needs to get applied to the A, and it needs to get applied to the B. So if we apply to the A, that will give us A to the power of 5, and if we apply it to the B, that gives us B to the power of 5. And that's a B, not a 6. Okay, so then our final answer would be A to the power of 5, B to the power of 5. Let's look at another one. So we have 2xy, and all of that is cubed. So we need to apply that power of 3 to the 2, to the x, and to the y. So that'll give us 2 to the power of 3, and that'll give us x to the power of 3, and that'll give us y to the power of 3. Now remember how much math loves simple answers. If you can make it simpler, you always should. We can solve out 2 to the power of 3. That gives us 8. So we have 8, and then we have our x cubed, and then our y cubed. So our final answer is 8x cubed y cubed. Okay, so that's the first law. Products, when you're raising a product to a power, the power has to get applied to each factor, each piece that made up the original product. Let's look at the second law. Second law has to do with division or quotients. So if you have a quotient, or in this case it kind of looks maybe more like a fraction to you. So we have A divided by B, or A over B, and all of that is being raised to the power of n. It's similar to the product law in that that power of n has to get applied to every single piece of the quotient. So we apply the n to the power of n to the A, we apply the power of n to the B, it gets applied to every single piece inside that original quotient. Now, the caveat here, the condition is provided that B does not equal 0. If B were to equal 0 here, we would have something divided by 0. We can't do that. We can't divide something into 0 parts. So that answer would not exist. So that's why there's that condition here that B can't equal 0. The bottom of that quotient can't, and in the end, equal 0, or else this isn't going to work. So written out for you. When you have an algebraic quotient raised to a power, that power needs to be applied to each piece of the quotient. Let's look at a few examples. So first one we've got m divided by n, and all of that's raised to the power of 4. So I'm going to work sideways here because it's a little bit easier for me. You would, of course, work down your page, not across. So we take that power of 4, and we apply it to every piece inside that quotient. So that's going to give us m to the power of 4. Here we go with the pen again. It's doing so well on the first slide. So m to the power of 4. And then on the bottom we have n, and that also needs to get raised to the power of 4. And that's as simple as we can write that. So m to the power of 4 over n to the power of 4. So let's look at another example. So we have 2 over b, and all of that is cubed. So that cubed needs to get applied to the 2, and it needs to get applied to the b. So we're going to take 2 and apply the cube to that. And we're going to take, let's just color that in and pretend we didn't have to mess with the pen. So b cubed. So we can actually solve out 2 cubed, so we do it. So that gives us 8. A little bit of a disjointed 8 over b cubed. So remember, math loves simple answers, make it as simple as you can. So 8 over b cubed would be your final answer. Now let's get to the more complicated stuff. We start putting it all together. So if we have something like 4a squared b, and all of that is raised to the power of 3, that means that we're going to have to apply the 3 to the 4, the 3 to the a, and the 3 to the b. So we have 4 cubed. Now, a squared raised to the power of 3 is a power to a power. So think back to our index rules, our index laws that we talked about in the last video. So power to a power means you multiply the exponents together. So that's going to become a, because the base doesn't change, and we multiply 2 by 3. So that gives us to the power of 6. And then b cubed is just b cubed. Now, math loves simple, so we got to make that simpler. So 4 to the power of 3 is 4 times 4 times 4. So that gives us 64. And then we have a to the power of 6 and b to the power of 3, or b cubed. So that would be our final answer. That's as simple as we can make it. Let's look at one last example. So this one has a quotient, but it's also got some products working inside that quotient. So the bottom line is that power of 4 has to get applied to every single piece of that original quotient. So that leaves us with 2 to the power of 4. And then we have b to the power of 4. And then that's over 3 to the power of 4. And then a cubed raised to the power of 4 means power to a power, so that means we're going to multiply together the exponents. So that gives us a to the power of 12. So, simpler, 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 simpler. 2 to the power of 4 means 2 times 2 times 2 times 2. So that gives us 16. And b to the power of 4 remains over 3 to the power of 4 is 3 times 3 times 3 times 3. So that gives us 81. And we keep our a to the power of 12. And there you have it. Those are some expanding laws. We're going to get lots of practice on that to make sure we're all okay with it. But that's it for this video. Thanks for watching.